of course, the most
Okay, so I think Vipula did a good job of covering how you should be setting up a single application, specifically in this case with Laravel. And what I'm going to be covering is more of a general architecture setup. So the points that I'll be covering here will be useful for Laravel applications that like people covered, plus for general PHP frameworks, or even if you're going with pure PHP, or even a different language. These are essentially some baseline high-level topics that high-level areas that you should be covering if you want to build scalable applications. So let's get started. I think Zara would have covered some of this. I'm a tech lead at Renfrew, Gapstars, and I've been in tech for about 15 years now. Mostly worked on PHP with a smattering of Java, Node.js, and JavaScript. And in the last couple of years, I've been getting into AWS, and I'm a certified solutions architect and associate at AWS. And I'm Joe Manatee on Twitter if you have any comments, feedback, or if you want to dispute anything I bring up here. So scalability of an application. I mean, first we should probably define what scalability is in the computing sense. It is a property of a system to handle a growing amount of work by adding resources to the system. So if in the previous examples, people were talking about running, say, about 12 applications in that droplet. Now, what if we were to actually scale that up, and if we were to say that the users, there's going to be 100 users connected at the same time, can the droplet handle it still? And what if it was 5,000? So how does the system need to scale if the user and the actual process workload increases over time? And as a business, you generally want to have that increase, because that just means that your business is taking off, and it's a good thing to have. So here we'll be specifically talking about scaling horizontally. Essentially, you have vertical scaling, which is getting larger and larger servers, and then you have horizontal scaling, which is essentially adding in more servers across your network so that you have more workers to actually serve all of the applications. You have different architectures like monolithic, microservices, or service-oriented architectures. Depending on what you have right now as you're starting your business, or what you're working with already, it's going to depend. There's no one size fits all. Generally, all of these patterns have pros and cons. For example, monolithic might actually be faster, but is not as easily scaled. Microservices will let you actually scale and set up a CI/CD pipeline and deploy fast. But on the con side, it is pretty complex in terms of monitoring to set up. And SOA is kind of you still have all the benefits of having services in there, but it's still a full stack application, and you can't really push out components of it without too much, like a lot of work in there. When you're building an application of this type, you want to think of it in a stateless term. I think for anyone who's unfamiliar, when you have one server, every request will go into that server, and every request will have the context to actually serve the request. What that means is, when you're logging in and the cookie actually goes with the request, and it basically says you are user X. When you have multiple servers, that cookie might not exist in the server that originated your login, your authorization request. So depending on which server it is routed to, you're gonna maybe be logged in, maybe be logged out. So when you're building these kind of scaled applications, you want to think in terms of stateless, and you essentially want to have all of the information for that request go out with each request. And you want to have a global state which is accessible by all of the workers. So that way, all of them can serve any requests that are coming in. Decoupling is very, very important here. If you have all of your services tied to each other, you can't scale them independently. You can't have service A with 100 workers and service B with 20 workers, just because any workload that comes into service A is also going to affect service B. And you don't want that kind of tight coupling. You want to have it loosely coupled. And work asynchronously. Be lazy here. Essentially, put off any work that you can do to the backend to be done at a later time. and just make sure to serve the user's request as fast as possible, because the more requests you serve, the faster it can move on to a different request. So why are we talking about PHP here? Basically, the talk itself is about PHP, but I know these patterns do apply to general applications in different frameworks and different languages. But specifically PHP, it's still a very popular language, still in the top 10. New versions are definitely getting faster, and you have a large talent pool. I think every one of us here knows PHP developers. Even it's a language that a lot of people start out with. And it's very easy to get into, which really helps. And then again, the active community support. Having a large community means that someone somewhere has solved the problem that you're already facing. And essentially, it really, really helps in being able to just go out and look at a solution that someone has worked on and get either inspired by it, or just, if it's open source, just include it in your application. And that really helps. And this is just like a 10,000-foot view of a basic, highly available application. We'll cover all of these in detail, but essentially, you have the load balancer, which will be accepting all the requests, then the target groups, which kind of funnel the requests. Then you have either a router or an edge proxy, depending on the configuration. You have all the hosts and all the caching and all of the background services. And then the database and the actual static assets being served off a cloud infrastructure, cloud CDN. So we'll be covering all of these pieces in detail and then kind of coming back to review. So load balancing, the load balance is where the request terminates from the user side. So you will handle all of the SSL, the TLS terminations, and make sure that the load balancer accepts all requests coming in. Depending on the load balancer, it is able to then funnel that request to a worker that is available. As you can see in the picture here, if your load balancer isn't really doing a job, it's gonna just queue up all of these requests, and it's gonna take up longer for the user to actually get the request served. One size does not fit all here. You have a lot of features that you want to look at when you're selecting the load balancer that you want to work with. There are features such as weighted load balancing, rate limiting, health checking, checking whether workers are actually healthy or not, and newer features such as HTTP2, gRPC to make sure that all of the protocols that your application works with is connected and can be connected. Then you want to also have things like hot reloading. If you update the configuration, does the system actually require a reload? Every time your system goes down, that is people not getting served. And if you are a high volume user, a business, that means that is essentially money that you are not making use of. And basic things like routing and short circuiting. Short circuiting here is if a request goes to a worker and for whatever reason the worker is actually unhealthy or it is taking too long to process, the load balancer should be able to cut the request off and then reroute it and retry it. If it doesn't do that, unhealthy workers are just going to take up too long in trying to serve a request that isn't there. Some options that we can go with. You have HA proxy and Nginx, which have great support for PHP via FastCGI. If you use one of these, you won't actually need to have a separate web server. You can just connect them through FastCGI and have them route all of the PHP output directly via the load balancer. You have newer load balancers like Envoy Proxy. This is actually created by Lyft. They're a cloud native proxy, so a lot of these features that they have are specifically related to application setups like that use something like a service mesh, where you have a lot of services. They need to self-register, they need to check, they need to do intelligent routing, and you need to do health checks on them to make sure that everything is running. Envoy Proxy is a great choice. It's something that I've worked with, and it's very, very fast, and it makes it really easy to set your services up, because once you set up your services and each service has an Envoy sidecar in it, you don't need to think about the topology of your network anymore. Envoy will take care of routing. Envoy will take care of health checks. All you have to do is just either bring the services up or bring them down, and Envoy will completely load balance it for you. It's pretty easy to work with. And then you have, the AWS load application load balancer. This is, I think everyone knows this. This is kind of expensive, but it does pretty much scale to any amount you want. It is very fast and very with elastic scaling, very scalable. So containerization and deployment. Not the type of containerization that we want. Essentially, containerization here is you basically take your application, and the old way of deploying it would be basically putting it through Git and then deploying it to your bare metal server and then serving everything off that application, off the server. In the modern, with the CI/CD way, you essentially have all of these in either Docker or Kubernetes or some type of containerization mechanism, and you let your container orchestration service deploy this for you. So this really helps when you're working with microservices or services, because each service can be an individual container, and all you have to focus on is making sure that all of them are defined correctly, and then your container orchestration application is going to take care of it for you. So when you're setting up the infra here, when you're serving very large amounts of requests, so a system that I was working with was basically looking at 3,000 to 5,000 concurrent users. And when you have that many users, you're going to need big servers, and you're also going to need a lot of application support systems around it. These can be manually set up, but the first time we did set those things up manually, it took us about 7 days, and that's not really tenable in terms of being agile and fast moving in these days. So you want to use services like Terraform, CloudFormation, or Ansible to automate your infrastructure setup. So this is code as essentially infrastructure as code, and these would completely deploy your infrastructure from zero to completely available in a matter of hours, even as long as everything resolves correctly. These things will take care of it for you, and this is something that you need, because if you want to, if you have some kind of fatal downtime or something, and you need to put everything up again, these are the services that you want to use. And then once they are up, to configure individual servers, you can use things like Puppet or Chef. The container orchestration essentially is the system that takes care of deploying and not the deployment part of it, but like the managing of all of the containers inside your servers. So if you go with Fargate, where it is serverless, or if you go with something like ECS and EC2 hosting, regardless of what the actual host is, your container orchestration system is gonna deploy the service, make sure it's healthy, make sure it's available, connect all of the the metrics around it, and give all of that observability for you. And it's not like it's a big deal when you have only about 10, 15 services, and you only have about 3 or 4 hosts. But the moment you go into hundreds of services and tens or dozens, sorry, I think I disconnected.
So I think we had a slight issue there, and John and Vipula have currently disconnected. We'll check on that in a moment. Vipula is back, and John is also back. A little bit of entertainment in the middle of
everything
internet. Good, guys?
Yeah, home internet. You know how it is in the times of Corona. This is the new. This is the new normal. Let me just set up the sharing again.
No worries. Back to you, John.
So I think I cut off on the containerization bit. So I'm just talking about the orchestration. And so I think the orchestration is essentially the, think of it as the brain of your highly available system. That's the one essentially that keeps all of the services up, and if a service goes down, it knows to put out new services or alert you. And you need that management, and it needs to be automated. And then you have your build pipeline now, very important here, because regardless of everything that you have, if you can't deploy quickly, and if you can't automate that deploy, you are pretty much stuck. Because when you're talking about dozens of servers, doing a manual deploy across all of these servers while handling with versioning, while dealing with uptime of old applications, it becomes a very, very complex thing. And then this is why you basically have all these pipeline and workflow systems where they will manage the building of your application, the automated testing, and then once it is fine, pushing it into master and then pushing it out to your orchestration system, which will deploy these onto all of the servers that you have. Code Pipeline is an AWS native service, and then you have paid services like Circle CI, which also integrate with all of the providers out there, or even your bare metal server. And then you have open source services like Jenkins, which will actually help with the same feature set. It's just that you manage it, and you don't really have a fee to pay. And then we come to asynchronous processing. In the early chart, this is where the queues and the caches come in. I think like the illustration here with the image is that you want to think of the order of things when you're building a highly available application. You can't depend on things being in the order that you put them out, because depending on which worker takes the background work and in which order it was received, they might be finishing processing of them, of the work in a different order. And it's a normal thing, and you just need to be aware of it so that when you're designing the system, it's taken into account. So you have queues like SQS in AWS, and which is a fairly basic queue service that is provided by AWS. I think that's something that you can start with. But for larger payloads, you should go for something like RabbitMQ or ActiveMQ. These can handle very, very large payloads, and these can handle these payloads at a very fast rate as well. And then on the smaller side, you have Redis, which starts out as a memory, so that you can use it as a queue. And you can actually connect it with Laravel pretty easily as well if you're looking into that. It's just a couple of configuration steps. And it just makes it easy for you, because you can push all of the background processing to a separate service, which is fine-tuned for this. So your web application is not actually spending any time on this at all. And here the focus should be like, you have these background workers actually processing these tasks that you put in, and you need to have insight on these tasks. So you can use tools such as PM to supervise and run it, to make sure that your services are actually running and being productive. And even Laravel Horizon is a nice dashboard on top of those workers to actually let you see what they're getting up to, what their throughput is, and make sure that everything is going well. Yeah. Then we get to caching and state here. Again, what I said earlier was the problem with having so many servers is that when the request goes from server to server to server, the context information around that request is not taken with it unless you design for it. So when you're building an API, you need to build it out as a stateless API, because you want to have the state available in a global state, like a global service like Redis or Memcache or even a database, and have each worker be able to access that. Because without it, passing on the information like cookies in the request will just might end up that the server that you actually was served the original request is not the one that is being served now. You do have workarounds like using sticky sessions, but there are problems around. There are problems with that as well, because the application is now less scalable. On the caching side, I think many of you will be familiar with this code. There are only two hard things in computer science: cache invalidation and naming things. Naming things, I think we all know, we've all struggled with naming the things correctly. Sometimes I spend minutes, just in the naming of a variable. And the other thing is caching. The problem with caching is you can put everything you want into the cache. You can make it really, really fast. But the problem is actually in clearing the data and, basically just getting updated data. So for example, when you create a new user, you might put that information into the database first and then put that into the cache. And then when your API is serving this information, you essentially will be pulling it from cache first. Now, pulling it from cache first is fine. Now, what happens when the user goes and updates their profile? And now, what happens if you're a highly available application spread across multiple data centers, across multiple regions? Now you need to go and update the cache in multiple areas, and depending on where this user information is being pulled from, you might get inconsistent data. And there are many methodologies to work with where you can use to make sure that you have a consistent cache, but it's definitely something you should be thinking about, and not something that you just put out there and think, oh, I've added caching, my application is not going to be fast. But that's, it's rarely going to work that way. It's just going to introduce more problems to you. And the caching services that you can go for, you have Redis with data structures and persistence. Redis is, adding new features every version, and they are really, really good at adding all these really useful data structures, queues, lists, sets that you can use in your application, and it's very fast because it's still in memory. They do have backups of persistence, so do check that out. You have memcache, the original key value store. Again, very, very fast, but it's essentially used as a key value store. So you're not going to be able to set in more complex data structures. And on the AWS side, you have Elasticache, which provides Redis or memcache in the backend, and you have like a consistent API in which to use. So logging and monitoring. Essentially, if you don't have monitoring in your application, you don't really have an application, because you don't know what is going on inside. You don't know when the application is failing. For all you know, you might be running an ad campaign. You might be having everyone log into their account via the ad campaign, and your login might be failing because there's some error in the login page. You won't know this unless you have some form of error tracking, some form of bug tracking, and reporting and monitoring in there. And if you don't know this, then that just means that you're not going to be able to fix it until very angry users call you up and ask you what's going on. So you need systems in place that will automatically do these things for you. You need fast reporting of issues. You need the observability of this issue developing. So you need to be able to see how many users are actually affected by this now, and the trend developing, know that this is something that you need to actually go out and fix. You need to find out where the problem is, which is where the traceability comes in. And you need to collect as much information around this problem to then have a developer fix it. The worst thing a developer can actually be faced with is like a random 2-sentence description of an error with no context, and they'll be lost trying to find out how they are going to fix this, because they can't recreate it. And if a developer can't recreate it, then that's pretty much the end of it. You then need to marshal the effort, and the issue might be across services, across teams, and you need to bring all of this organization, all of this information together in one place, and then put the fix, and then you push out the hot fix. And again, this ties back to the CI/CD system that you have in play. If you can't actually deploy a hot fix in a very short time, you're now going to be stuck with a broken system, and that's again money in your that you're not actually getting into yourself. So for error tracking, you can use services like Sentry, or there's so many other services which are out there. Sentry is also self-hostable, so if you want, you can run the open source system and spin up some infra for yourself, and you can run it. For performance monitoring and for metrics, you have services like New Relic and CloudWatch. Both are paid services, or you can host your own with Apache Skywalking API monitor. You have Zipkin and Jaeger for service tracing. This is really useful when you have multiple services and all of them are spread across many, many servers. And you need to figure out where the problem started, where it's getting acute, and then which services are affected. So those are all things you need to know. And for logging, CloudWatch and Elk are fairly large scale logging platforms. You can go with simpler tools. There are many, many available. I just mentioned these two because these are capable of handling everything you can throw at them. Elk is very, very large and it's powered by Elasticsearch. So you can imagine that it can handle millions and millions and millions of rows of logging coming in at it every day. It's not a problem. And then on the uptime and alerting, you can use things like Pingdom and PagerDuty to make sure that your monitors are all up. And these services can also then connect to things like CloudWatch and give you automated errors and make sure that all of your information is in one place. And you can then react to that information and make sure that all of your customers are also aware of everything going on. And then rounding out, we have things like the database. I think these are fairly basic things. We want to look at making sure that you have automatic failovers, automatic backups, and making sure that whenever the system fails, the secondary kicks in and the system is able to perform. User proxy, this will help you with managing the connection pool in databases. RDS has RDS proxy, which is fairly good when you have a large number of requests connecting to the database, and it'll help round that out. Benchmark every step of the way. When you're building a system like this, it is very important that you know the blockages and the bottlenecks at every step of the system being designed. It's like a terrible thing to actually commit to the architecture, build it out, and at the end find out that either your queuing service or your logging service can't handle the volume that you're thinking. So these need to be benchmarked at every step and make sure that each step of the way you can basically make sure that everything is okay and problems are identified. Use Postman for automated testing. There are other services as well, but Postman also runs a monitor, which is very useful. And security, which I'm only touching on here, but which is an entirely separate topic with this, which should be its own talk. At the least, you should be running automated scans to make sure that you don't actually go and accidentally even open up any ports that you shouldn't be. And simulate downtime and run drills. Just like in the army, when these bad things happen, you need to make sure that your team is aware of how to respond to these things, and having a playbook and running a simulation once in a while will really help with this. And then the next stage is essentially you should be at least running on multi availability zones, but look at multiple regions as well if your budget is covering that, and if it is an actual requirement of the system. Because what happens if your data center gets hit by a comet or an asteroid, and it's basically going to go down, and your system goes down. And I think you've seen outages like that with whenever AWS goes down. Services like Netflix also suffer, although nowadays they don't go down completely because they're spread over multiple regions and the content is served from many, many places around the world. So yeah, coming back to the system that we reviewed earlier, this kind of application that is designed in all of the main features that I spoke about can handle very, very large payloads. I've worked with systems like this, and the only limiter here for you is deciding the exact technologies that you want to use, and then figuring out how many servers. So it becomes like a cost thing. On the foundation side, it's not a problem to actually go out and build this and have it serve a lot of customers. So I hope you found that interesting, and we'll be taking, I think, questions, and I think I'll just pass it on to Zara. If Zara is, yeah.
Hi guys. So thanks John, thanks Vipula for sharing all that with us. Opening the floor out now to some questions. We can see that there are some that have been asked in the question column on our right-hand side as well. Vipula, John, would you want to take over the questions that have been asked?
Sure. Viplav, why don't you go first, I guess, with the ones
I
emerging?
think I already replied about 3 questions.
Okay.
Yeah. So
There are
Yeah.
the new ones as well at the top.
Sure. Let me, so I think I see one from Gihan. Is it possible to use PM2 with Docker? Can we use network load balance instead of ALB? Yeah. So PM2 with Docker, yes. So PM2 is interesting. So Docker works with having one service, one process running at a time. And the thing with PM2 is that PM2 never goes down because the moment that a process goes down, PM2 will just spawn a new process. So PM2 is always the process ID one in a Docker system. But they've actually put out a version that works with Docker, which actually helps here. So PM2 will handle the service, the monitoring on inside Docker, and it will basically bubble up those events up to Docker. So you can use it, you just need to make sure that you're using the Docker configuration. And number two on that is, can we use network load balance instead of ALB? You can, but the problem here is those are very different use cases. So the ALB works on the layer 7, so with HTTP, and it can have routing rules which the network load balancer, which will be working on the TCP level, can't handle. So if you're going with, setting up a load balancer, which is directly connecting to, say, something like your MySQL backend or some kind of other socket server, then of course you can use the network load balancer. But generally, if you're running an application, you want to use the application load balancer because it has all of those rules. It has a lot of features that are available only on the application level. And I think upon new application update, how can we invalidate end users' browser cache? So this is, I think, something that the CDN will handle. Essentially, you want to have E tags, and you want to make sure that your assets are versioned. So every time the CI/CD pipeline pushes out a build, the build will always have a version attached to them. So when your application is deployed, these will have query strings, which will then go and break the cache on the browser side. You can set up things like, I think, CloudFront and even Cloudflare to cache these regardless of the query string. But generally, you don't want to, because you do need a way to pass the user's cache in time and update goes through. I see one from Jack. How do you focus to deal with catastrophic failure in a highly available application? So I think, yeah, the asteroid example that I brought up earlier is, if your data center goes down and if you're not multi-region, your system is going to go down. So one way is to be multi-region, which is again more expensive. But the other way is to make sure that you have tools like Terraform and your infrastructure to be deployed in an automated fashion, because then the moment the system goes down, what you can do is have the infrastructure up in a different region that has availability, make sure your databases are backed up in those regions and available, and then basically deploy your databases and have the application up. And that would be the way for you to actually deal with catastrophic failure, because it's all in how fast you can respond and how fast your automation systems will deploy. Vipul, you want to take a couple?
Yeah, okay. So, Kasun, you have asked about the Lumen framework. So basically, Lumen, just think as it is Laravel, but you don't have the blade aspect of it. So basically, all the view components and the view component logic is removed. So technically, there is not much of a difference between it, but I don't use Lumen unless you are entirely focusing on building an application based on an API. But if by any chance, if you plan to return at least one single bit of HTML through your API, then of course go with Laravel, because using Blade will ease your life a lot. Okay. And about Rashad Shamika. So yeah, so of course, for based on my personal experience, we used to do I was in the field for almost about 20 years now. So we started with like back in PS4. So we used frameworks like WordPress, uh, Joomla, all sorts of things. So the point is when you can't actually do a direct comparison between a CMS and a framework, because Laravel is actually a framework. It allows you to build from scratch, but WordPress is something where it gives you the tool set and you can just directly copy the code and build your application based on it. So unless you want to go with a custom application with custom data objects and a custom database, I suggest you to stick with WordPress unless you want to go for it. But then again, the next part is Laravel Nova backend, where it allows it. It basically gives you a backend similar to WordPress, about say about 80% similar to WordPress, with the option for you to customize. So you get the option to create a Laravel module, and do the data structure and do the controls, and use Nova as the backend. It is extremely simple and straightforward. But the only thing is, Nova goes on a subscription, so you just need to get one subscription, and you can continue building on that. So that is actually the point. But then again, don't go for something like an overkill by using Laravel, where you can just easily download a WordPress template and build a website. So that's my answer for that. So I see one. What's the best way to update old Laravel applications? Okay, so 5.7 to 8 is actually a tricky. So we recently tried to do an upgrade from 5.6 to Laravel 7, and it gave us a massive head of a time, because it, like the framework is extremely different from 5 to 7. So you get multiple different modules, and basically the router is also changed. So if you want to do that, it's a massive task. But if by any chance you can do a rebuild, basically keeping the same code and only moving the construct, like the controllers and the template, then I suggest to go with that path without directly trying to improve the code, like without directly getting the entire same code base, because it actually took us about a week to do the entire migration, but we used all the latest versions and the latest features of Laravel 8, such as the blade components and so on and so forth. So it allowed us to actually do our own custom architecture for the UI and the way we load things, and it was a success. So what I can suggest is, don't try to do a immediate one-to-one update by updating the core files, but best is to just pull out your logic and try to use the same database, but with the latest code, the latest version of that. I think that would be the most wise method. Super. So yeah, any more questions?
I think I'll be writing about a couple of these topics a little more detailed, and I'll be sharing them in on my Twitter. I guess you can follow there. I think we've run a little over.
Definitely run a little over, but thank you guys so much for tuning in. Thank you, Vipula. Thank you, John, for such an informative session. And do follow us on our Twitter. That would be at GapstarsIT. Follow us on our Instagram, our Facebook, and our LinkedIn for updates that we will be sending your way. This is just episode 1 of the Explorer series, and I'm so happy to see the turnout. We will be posting new updates, new episodes coming in the next couple of months, covering different topics within the tech sphere. So this has been PHP. We'll be covering JavaScript, Java, different types of front-end and back-end technologies as well. So thank you guys for tuning in, and do keep in touch through our social media. If you guys also want to explore an opportunity at GapStars and help to change the world with PHP technologies, Do check out our GapStars website and apply at our PHP positions. Thank you everyone for joining in. We will be sharing recorded sessions of this webinar as well with all of our attendees. And yeah, have a great day, stay safe, and take care, guys.
Thanks, guys.
Thanks, guys. Stay safe, everyone.
Thanks, guys. Good night. Bye-bye.